Alright, this is the beginning of section 2.3 on long and synthetic division of polynomials. Today and tomorrow we're just going to talk about the process of dividing with polynomials, and we'll get into on Thursday why we do it and what it's for. Alright, so we've got 4 examples today, 2 for long and 2 for synthetic. Okay, so our first example is 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2, and we're going to do that using long division. Okay, so we're going to set it up as 6x cubed minus 19x squared plus 16x minus 4. We're going to divide it by x minus 2, and now we're going to use our regular division rules that we've been using since we were, 3rd and 4th grade. So I'm going to begin by figuring out what I need to multiply by to turn that x into this 6x cubed. So x times what gives me 6x cubed, and whatever I figure out that is, that's going to go up here at the top somewhere. Okay, so x times 6x squared is going to give me 6x cubed. So since it's 6x squared, I'm going to put right above my x squared term, which is here. So I'm going to put a positive 6x squared right there. And then I'm going to remultiply this 6x squared I just found by everything out front. So I'm going to distribute it. So 6x squared times x gives me 6x cubed. 6x squared times negative 2 gives me negative 12x squared. And I'm going to subtract these two quantities. So I do that, and when I subtract, it's actually going to be easier if I show this as addition and then changing the signs on the inside, really just distributing those two minus signs. Okay, so 6x cubed minus 6x cubed, those are going to cancel out. That should always work out that way. Negative 19x squared plus 12x squared is negative 7x squared, and I'm going to bring down my remaining terms, plus 16x minus 4. And then I'm going to start the process all over again. X times what gives me negative 7x squared. That's going to be a negative 7x. And so I'm going to multiply that back through again. So negative 7x times x gives me negative 7x squared. Negative 7x times negative 2 is positive 14x. And now I can go ahead and subtract. But once again, I'm going to subtract that quantity, so it's going to make that plus, plus, minus. These cancel out because they're opposite. 16 minus 14x is 2x. Bring down the minus 4. And I'm going to do this process one more time, but I can't because, well, I can do it one more time. I take that back. Okay. X times what gives me 2x. That's going to be a positive 2. And now when I multiply that 2 back to this binomial in the front, 2 times x is 2x. 2 times the negative 2 that was up there is negative 4. And now I'm going to subtract this and change that to plus, minus, plus. Those cancel, and I'm left with 0 left over, which is really good news because that means my remainder in this problem happens to be 0. We'll talk about the significance of that later. But my final answer, okay? When I divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2, I get an answer of 6x squared minus 7x plus 2. Minus 7x plus 2. And just for fun, because we're going to need it a little bit later, if I want to write that remainder, because sometimes we do get a remainder, if I want to write that remainder, it would be plus 0 over x minus 2. The x minus 2, remember, came from this guy out front. But that's my final answer. Okay. In this case, I don't really need that 0 over x minus 2 out there, so my full answer is just that guy right there. Okay. So that's long division. Let's try one more. Okay. This one's a little bit messier. This time I've got negative 2 plus 3x minus 5x squared plus 4x cubed plus 2x to the fourth, all divided by x squared plus 2x minus 3. So I've got a, let's see, a 5-term polynomial divided by a trinomial. Not quite as easy, but I'm going to set it the same way. First thing I'm going to do is rewrite the inside in descending order of my exponent. So I'm going to actually flip the order of this around, make it 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2, and I'm going to divide that by x squared plus 2x minus 3. And I'm going to repeat the process all over again like I did on the last one. Okay? So I'm going to start with x squared times what gives me 2x to the fourth. Well, x squared times what gives me x to the fourth, that's got to be another x squared. So I've got 2x squared. 2x squared times x squared gets me back to 2x to the fourth. 2x squared times 2x gives me positive 4x cubed, and 2x squared times negative 3 gives me negative 6x squared. I can now subtract these quantities, change that to plus, minus, minus, plus. These cancel out, and I'm left with x squared. I'm going to go ahead and bring down the 3x and the minus 2. Okay. I'm going to do that process again. X squared times what gives me x squared? Well, that's got to be a plus 1. I distribute that 1 through, I get x squared plus 2x minus 3. Subtract those, plus, minus, minus, plus. And that gives me x plus 1. And that is my remainder. So my final answer when I divide those two polynomials is 2x squared plus 1 plus my remainder of x plus 1 over x squared plus 2x minus 3. And again, we'll talk about the significance of that remainder a little bit later, but this right here is my solution when I divide those two polynomials. Okay? So long division, not always fun. Okay? It works though, but what most of us would prefer is synthetic division. That's what we're going to do next. Okay? So this is actually the same as the first problem we did. You'll notice it's still 6x cubed minus 19x squared plus 16x minus 4. We're dividing by x minus 2. Something we need to keep in mind with synthetic division is with synthetic division we divide by not the factor, this is the factor, we divide by the solution. Okay? So if you recall from the last section, if the factor is x minus 2, we set that equal to 0 and the solution would be x equals 2. This is what I divide by. Okay? So the way I set up my synthetic division is I don't care about the variables, I only care about the coefficients. So I'm going to write all my coefficients in order from highest power down to the lowest power, making sure I don't skip any. In this particular problem, I see x cubed, I see x squared, I see x to the first, and I see the constant. So I have all my terms. If I don't have them all, I need to make sure I put a placeholder 0 in there for it. But I'm going to write all those coefficients as 6, negative 19, positive 16, and negative 4. Those are my coefficients from here. Put this little box. And then I'm going to divide it by that 2 that I found there. Okay? Alright. And this is easy. Synthetic division is super easy. But remember, we can't divide by some ugly polynomial like we did on the last one. We have to divide by the solution, not a factor. This is a factor. This is a solution. We have to divide by a solution. Okay, so you have to know what it's equal to. So this process is pretty simple though. Here's my synthetic division setup. I have all my coefficients in order from greatest to least as far as their power up in the original problem. And then my notation goes, I'm going to start with that first coefficient and it comes straight down. Always, always, always. That first coefficient, no matter what it is, it comes straight down. And then from there, I'm just going to multiply this number by the divisor and work my way through. So 6 times 2 gives me 12. And then I'm going to add. So this is where long and synthetic are different. Long division, we subtracted. Long division, we add. Negative 19 plus 12 gives me negative 7. Negative 7 times 2 is negative 14. 16 minus 14 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. This is once again my remainder. Okay, that last term is always the remainder. This right here, although it doesn't look like it, this is my solution. Okay, the way the solution works is we start with our original problem had a highest power of x cubed. So when I write my solution down here, this new one has a highest power of x squared. And all I have to do is put those variables back in, and I get 6x squared minus 7x plus 2, and then plus 0 over x minus 2, because again, that 0 was my remainder, and we were dividing by the x minus 2 from up here. And there's my answer. And if you think I'm crazy, if you think I did some kind of weird magic, that is the exact same answer that we got when we did long division. 6x squared minus 7x plus 2. There it is. Okay, so we'll do one more and then we're done for the day. Okay, so here we go. So here's the inside, x to the fourth minus 10x squared minus 2x plus 4. We're going to divide it by x plus 3. Remember, that is a factor. I need to solve that first. So x plus 3 equals 0. Gives me a solution of x equals negative 3. So we're going to divide by negative 3. And then inside this box, I bring down my coefficients. But if you haven't noticed yet, I said that we had to have all coefficients for each term, including ones that don't exist, and I don't see an x cubed term. There's an x cubed term right here, I don't see it, so it has a coefficient of 0. So we're going to put a placeholder in there. So the x to the fourth has a coefficient of 1. X to the third, which does not exist in this problem, has a coefficient of 0, so I put it in there. X squared is negative 10. X is negative 2. And the constant is positive 4. So now I'm going to do my synthetic division, and this process is super simple, does not take very long. Bring down that first term, it's a 1, and then I multiply and add the rest of the way through. Negative 3 times 1 is negative 3, add those, I get negative 3, multiply again, I get 9, add those, I get negative 1, negative 3 times negative 1 is 3, gives me 1, negative 3 times 1 is negative 3, gives me a 1 again. So again, this is my remainder. And my solution is the rest of that. So our problem started with an x to the fourth power, so I reduce it by 1, so now it's x cubed. So my final answer is 1 x to the third minus 3x squared minus 1x plus 1 plus my remainder of 1 out of my original factor, which was x plus 3. And obviously you can omit the 1s, but I didn't because I wanted to show you. Okay? But that's it. That is synthetic division and long division. We'll work on this a lot in class, both Tuesday and Wednesday, and then we'll talk about how to use it later on. Have a good night.